Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to material science and engineering. Previously we discussed stress in materials and the different types of stress acting on objects. So in this video we are going to discuss the effect of that stress, basically what stress does to the object. So which is strain in materials. So just a quick review, that stress is the response to the applied external deforming force, the reaction force to the externally applied deforming force. So this reaction force per unit area of an object, that is called as stress. When an external force acts on an object, an internal reaction force is set up which is exactly equal and opposite to the externally deforming force, and that reaction force acting per unit area, that is called as stress. Okay, you can write it as the applied force, or you can write it as the reaction force, the internal reaction force by area. Both are the same because the externally applied force and the internal reaction force, they are the same in terms of magnitude. It is sigma, which is equal to force by area, and that is Newton per meter square in terms of SI and Dyne per centimeter square in terms of CGS. And the different types of stress which are there, which is tensile and compressional, which is normal stress, then tangential or shearing stress, which is sliding stress, and bulk or volumetric stress, which is uniform stress acting on all sides. Okay, so here the normal stress, they try to change the length of the material. Okay, tensile causes elongation, increase in length. Compressional causes shortening, decrease in length. Sliding stress or shearing stress causes bending of the material. Okay, which is measured in terms of this angle, okay, theta, if you remember this angle. Okay, and this stress, bulk or volumetric stress, tries to change the volume of the material. So this response or this effect to stress, the effect of stress on the body, that is called as strain. So when an external deforming force acts on a body, the body undergoes change in its shape and size. That change in shape and size can be increase or decrease of length, increase or decrease of volume, bending of the material, which is measured in terms of angle. So this leads to change in the dimension of the body. So what is strain is the ratio of the change in any particular dimension of the body to the original dimension. Change in any parameter to the original parameter. So the formula of strain is change in dimension, any dimension, whether it be length, breadth, height, angle, or volume, whatever it is, to the original length, original breadth, original height, original volume. Okay, that. So change in dimension or change in parameter by the original dimension or original parameter, that is strain. It is the effect of stress. Strain is the effect of stress, okay, applied stress. So there are different types of strain, like there are different types of stress, that is tensile, compressional, tangential, bulk or volume stress. Similarly, there are different types of strain. So this longitudinal strain is basically same, which is normal, tensile and compressional. Okay, it can be that. So longitudinal strain basically is when an external force acts on a body, it can lead to either increase in length or decrease in length. Increase in length in case of elongation, decrease in length in case of shortening. This is tensile and this is compressional. So this change in length, which is delta L, where the length increases by this much, here the length decreased by this much. This change in length divided by the original length, that gives us the longitudinal strain, which is measured in terms of, which is expressed in terms of epsilon. Okay, stress is expressed in terms of sigma, F by A, reaction force by area. Strain is expressed in terms of epsilon, change in parameter by original parameter. So here, in case of longitudinal strain, the parameter which is changing is length. So change in length, whether it is increase in length or decrease in length, whatever it is, that change divided by the original length, that is longitudinal strain. Okay, epsilon L is change in length by original length. Okay, this is longitudinal strain. It involves both tensile and compressional stress. Okay, then we have volumetric strain, which basically occurs in case of bulk or volume stress. So this leads to either increase or decrease in volume. Okay, volume can either increase or decrease. So here the increase in volume is expressed as delta V, here plus delta V, it is expressed as minus delta V. This is the original volume. Okay, this is here increase, this is here decrease in volume. So here the parameter which is changing is volume. So volumetric strain is change in volume, delta V, whether it is increase or decrease, it doesn't matter, to the original volume, V. This is volumetric strain, epsilon subscript V. So change in volume per unit original volume. Okay, that is volumetric strain, epsilon V. Then we have the shear, response to tangential or shearing stress, which causes sliding of one face over the other or bending. So it can be anything, whether it is a cuboid or cylinder, whatever. So here we are taking, let's say, a cuboid, a simple cube. So here the force is acting like this, or the external force like this. Okay, it tries to move one face over the other. So one face is movable, which responds to the externally applied force. This is the area of the face. So stress is F by A. In response to that stress, the movable face, it slides over the fixed face. This is the movable face. This is the fixed face. So this causes bending of the material. So this, the magnitude of this bend, it is measured, it is expressed as this angle, or the tan of this angle. Okay, tan theta, this angle, this. Okay, tan theta. So let's say this is the perpendicular distance and this is the base. So tan theta is equal to P by P. Okay, so this is the shearing strain or sliding strain or tangential strain. Okay, it is defined as the angle through which the movable face, which was originally perpendicular to the fixed face, gets turned or gets bent, or the extent to which the movable face slides over the fixed face. Okay, when it is deformed by the external tangential forces. So it is the tan of the angle of turn or angle of bending of the movable face with respect to the fixed face. Okay, the force is acting in this way here. So here we have discussed the effect of stress on materials. Okay, So the different effects of stress, which is strain, is categorized as longitudinal strain, volumetric strain and shear strain. Longitudinal strain causes increase or decrease in length. The volumetric strain causes increase or decrease in volume, and the shear strain, that is the sliding of the object or the bending of the object, which is measured as the angle of turn of the movable face with respect to the fixed face. Okay, this is longitudinal strain, this is volumetric strain, and this is shear strain. Okay,